just let us know, or we can just post links to some references where you can learn a bit more. Most of that stuff is here in the docs. We're working constantly on improving them, and we realize that they're actually growing quite big. So we're going to do a rework at some point in the near future, measured in weeks. But right now, what you can actually check is, and what we'll go through today, is a new section on agents under the DKG V8. This is the latest version of OriginTrail that was released just 2 weeks ago or a bit more, which increased the scalability of the DKG incredibly, and which actually now allows us to run internet scale applications on the DKG. And today we're going to go through this particular section, but this is not the only way to build an agent on the DKG. There's obviously you can build your own custom agent. So for example, if you already built an agent and you want to add the DKG inside, you can take one of these two guides specifically how to do that in a JavaScript environment or in a Python environment using the DKG clients. And in this specific case, how we can use it with the agents. But today we'll dive into this, which is the latest and most exciting, I have to say, development that I've seen, which is the ElizaOS DKG agent. What does this thing do, and why are we so excited about it? Because it's kind of well illustrated here. ElizaOS is this framework that has been recently launched a few months ago, but essentially allows you to really easily launch your own AI agent. You pick a model you would like, you can define its character pretty easily. Lots of agents popping up on the web and lots of integrations. Really interesting, really exciting. And what we're going to see today is a very large advancement in this capability. So these agents generally, they use some form of AI model, LLM, like OpenAI or whatever, or a local model, to basically, let's say, think. Because contrary to when you go to like something like classic interface, like, I don't know, ChatGPT, you're kind of speaking with a chatbot. So it only sort of reacts to what you tell it. The idea behind agents is they actually go a step beyond, so that they have some form of agency, that they can do something, ideally something you tell them to do, which is incredible because it opens up actually a lot more capability. And what we're going to see today is that if you add sophisticated memory to these agents, compared to just some basic types of memory that come out of the box, which are useful, but not as useful as knowledge graphs particularly can be, then we can get some really, really powerful stuff going on. And here you see on this image one screenshot example of a knowledge graph-based memory of an AI agent. This was actually generated by an agent. So here on the right, and we can actually go and see, we'll see in a bit, actually, this live on the DKG Explorer. Why is this such a big deal? Well, basically, if we zoom really out from this particular implementation that we're going to dive into today, zooming out, we're obviously, I'm pretty sure you all have heard about this concept of attention economy, where everything everywhere is all the time trying to grab your attention for obvious reasons, because it's a valuable resource. It's probably the resource or the thing over the past couple of decades, which is why, you know, the overwhelm of notifications and everything everywhere. And the sort of the economy started growing around this as pretty much the main currency of attention. Seems to be shifting into something called an intention economy. Intention being somewhat different. Instead of everybody trying to spam you like crazy with notifications, all the apps, all the whatever marketing outlets, or pretty much anything you tune in, and us being overloaded as humans, as employees, as builders, as whatever, with a ton of info from all the places, constantly cutting our focus and really shortening our attention span. There's a lot of this research, I'm sure you've heard, that attention spans have been growing or shrinking over the past decades. And so have the commercials, by the way. They designed them on TV so that, like, they fit into the average attention span. So used to be, I don't know, 30 seconds, it was 20, and then boom, all of the commercials are now like, fitting into that span of attention. Well, the intention economy tries to flip that in a way, and not to go too deep into the idea, but the idea is that you take back control. So it's not in a way a thing where somebody spams you like crazy and overloads you, but rather you can set up some form of intention. For example, I'm a big fan of science fiction. Pretty much a bunch of books here are science fiction. I got some SF from like 85, some year best annual collections and stuff. So I'm a big fan, and I really like certain styles. Like, for example, I'm not a big fan of the Dune because it's kind of like very fantasy-ish and colorful. And when I read a page about like how a costume of a character looks like, it kind of bores me a bit. So I actually didn't finish it. But when I read Asimov, who is different, who is much more to the point and rational and sort of conversational, I can read it for hours. So my intention for finding books about what I like, which is science fiction, the kind of like what Isaac Asimov writes, can be stored in the DKG as a graph, a very rich graph that literally explains this intention. And then instead of having somebody bombard me with random things that I don't care about, they could actually tap into my intention and then use this intention to understand, okay, you're not the potential customer for me at all because you don't like this thing. And at the same time, anybody looking for people like me, maybe to sell books or target me, whatever, they could find me. And this is something that I want. So because the DKG is an open permissionless knowledge graph, decentralized knowledge graph, things like this can be built. This is just a very simple example going from attention to intention economy. But on the other side, we can imagine agents taking those intentions of ours and doing something, and basically taking them as tasks. So if you describe what you want really well, and give the agent sort of a green light to go and chase it, you can make some really, really good connections in these, which is not something that knowledge graphs are great for. Now, I also understand that maybe some people on the call haven't had a chance to touch upon knowledge graphs, so we'll touch that as well. And why those are really cool. So actually, I don't have any slide on that, but I'll try to explain. You know what? I'm just going to go to Google and find something. So knowledge graph, let's see. Okay, first thing, Wikipedia. It's decent. So you can think of this as kind of a diagram that connects different things. And it's kind of a rudimentary knowledge graph where you have something like concepts, dogs, cows, whatever, or individual things like, I don't know, a dog named Jackie, whatever, and then this dog, has its characteristics and whatnot. But essentially, these are very common. All data everywhere is pretty much a graph, and knowledge graphs are just taking that to the next level. So I don't know. There's an example of Arnold Schwarzenegger, who was the governor of California, which is the capital of Sacramento, and who starred in Predator and so forth. And when you think about it, basically what you're seeing here is sentences structured as subject, predicate, object. So you have Arnold as the subject, who was the star of Predator, which is the object. So, and when you think about it, any sort of information can be modeled like this. I am a person, or I'm sitting at a table, or the sky is blue. Like all these things are literally subject, predicate, object type of sentences. And if you model them this way, you get something very powerful. You get flexibility because all of a sudden you can connect things in any way possible, which is really hard to do in such a flexible way with other data models. For example, if you take something classic like let's say relational database, SQL. For those of you who might not know, what you do here is basically similar to Excel. You create some tables and then you have, I don't know, table people, let's say, and then you have a table actors, and then you have a table movies, whatever. And then each of these tables has some columns, like, I don't know, movie name, year, produced by, whatever. And then you get this powerful structure. Relational databases are great, but they're not that flexible because for each of the things you want to describe, you need a table, and then you need to define some structure, and then your application on top needs to basically know that structure. So whenever you want to change something, or rather the models of your application, the objects, you kind of have to change these tables. You need to add new ones. And then if you want to make relationships between those things, like for example, between humans or actors and movies, you need to create some kind of some mathematical keys, primary, secondary keys. Again, very useful technology. Works really well. I'm a big fan of SQL, to be honest. But it's not that flexible. It wasn't designed for it. It's designed for something different. Knowledge graphs, on the other hand, super flexible. You can have a knowledge graph on some topic, and then you realize, actually, this is a knowledge graph about movies, but because it's about actors and these actors are people, I can also add, additional information in there that are not so much movie related. Maybe these people are also parents or like friends on a social network, and I can connect that, which doesn't have anything to do with movies, and it's just like as easy as pointing. But ultimately, this kind of basic structure is subject, predicate, object. So we have something called entities, things, and in the world of OriginTrail, they're called knowledge assets. So each of these things in a classic knowledge graph are like California, Sacramento, some entity. But in a decentralized knowledge graph, they are actually ownable entities. So I can create Brana as here, and this will not just be a graph entity, it will also be an NFT on the DKG that I own. And because I own it, I'm the only one that allows to update it. So I can update its content. For example, I can decide to connect it with some other knowledge asset, or I can decide to include it in a paranet and things like that. I can also transfer it, sell it, all these great things that come out of the box with NFTs. So in a way, knowledge assets are like knowledge graph NFTs. And you can see, for example, if you go to here, you can see them in action. So Decentralized Knowledge Graph Explorer, for example, we can take the DeSci example because I know that one looks really cool. And here you will see an actual knowledge graph of, I believe, some neuroscience. You can also explore the data here itself, like you can just go through the whole JSON, and we'll touch upon that as well. But basically what you see here is a bunch of knowledge assets in this nice looking new way that have been created for, I believe, SciGraph, the DeSci project being built on the DKG on the base blockchain. Each of these knowledge assets also has a UAL. A UAL is its unique identifier. You can also see it here, which basically, if you kind of look a little bit more deep into it, you can decipher it. It says it's a decentralized identifier on the DKG, rooted in the base blockchain. This is base mainnet because I know I have this extreme knowledge that this is the blockchain ID of base mainnet. This is the smart contract of the NFT collection, the knowledge assets, the custom collection, and this is 435, basically the ID of what we see here, which is this knowledge graph, knowledge collection. And each of these individual knowledge assets is, okay, you don't want to exactly do that, but each one of them is actually an NFT, so each one of them you can update separately. Which means not just flexibility, but also fine-grained control. You want to update some small thing, you can very easily. All you need is its URL. Okay, so I guess very, very short intro on knowledge graphs. Who uses knowledge graphs? Knowledge graphs are used by literally every major company in the world. And I mean, Google, Netflix, Amazon, Uber, NASA, IKEA, all of them. We see that at Knowledge Graph Conference every year, for example, in New York and all these places where we go to. And what they do is they create some really, really cool features, but they do them completely centrally, right? They do that for themselves. For example, Netflix uses Knowledge Graphs to recommend you shows to watch based on your previous history, which they store in a graph, and they find similar graphs of other people. So somebody somewhere in the world has similar taste to you, They found that, you watched a couple of different shows between each other, so they recommend you those shows that are missing in your graph. Or IKEA, for example, they do kind of a different thing. Let's say you buy a couch, and they realize that they know that a lot of people who buy couches, they buy also a lamp, reading lamp to read books, whatever. So they recommend you that because, and when I say they, I mean the website. So it's long-standing symbolic AI technology. It's proven, and actually there's a lot of stuff built out. And why am I saying this? Because you can use all of that stuff together with the DKG, because DKG is built actually on these standards for knowledge graphs, which are W3C standards. Okay, so back to this, to the agents. So what we're going to see today, I'm going to start a very basic agent, which uses ElizaOS and DKG, specifically this DKG plugin. And we're just going to walk through it. You can also see this documentation basically on the page, on the official docs. If you just go to the docs.origintrail.io, and you will find this AI agent section, ElizaOS agent. And essentially what we're going to use is this Eliza Graph Starter Kit. So this is actually, let me just open it in a new tab. So this starter kit is essentially a repo that is kind of the easiest one to get you going with Eliza and OriginTrail. It's called Eliza Graph. And the idea, again, is that we use the DKG as basically the infrastructure for knowledge graph-based memories for AI agents, and not just individual AI agents. The idea here is that they can collectively create memories. What does that mean? Well, we, in a sense, are building a collective neurosymbolic brain. The symbolic comes from knowledge graph part, and neural comes from this Gen AI LLM part, which those two technologies actually work really well together. The knowledge graphs are very precise and, like I said, flexible, but they're actually not that creative. So they're that rational part of the brain, and then you have the LLMs, which are very creative. You can ask it to write a poem, right, in the style of Shakespeare, but they hallucinate because they're just really, really well-trained guessers. You give them some data, you train the shit on that data, but ultimately, if you ask it, it might go wrong. So it's kind of the perfect fit between these two technologies because one completes the other, solves the problems of the other. So knowledge graphs with agents who can also hallucinate it because they are kind of the core of them is this, or at least the current agents that we see is the LLM. With knowledge graphs, you can make this very tight. They can basically use just the knowledge from the memories that were created in whatever way you decide to create them. And they will not hallucinate. They will use that knowledge, and they will actually have better ways to extract relevant information because as their memory grows, it becomes very big. Then that sort of becomes a classic information retrieval problem, which is something, for example, Google has been doing since forever, right? So if you go to Google and you type in a search term, what Google does is it finds what are the most relevant web pages for you. And it's been doing that since forever because Google has indexed the whole internet. And by the way, Google uses knowledge graphs for this too. But ultimately, what I'm trying to say is if you're building an agent and if it's going to have a lot of memories, it's becoming increasingly hard to find the right stuff. So knowledge graphs are really great with this. You cannot do some things with just vector embeddings alone, even though they're very powerful, or even worse, like if you're trying to do something classic SQL or I've heard people use JSON even, to search. Like basically searching through files can become very slow. That's also not optimal. Well, knowledge graphs help there quite a bit. So imagine all of the agents together creating these collective memories and being able to find the relevant stuff. This is really powerful. And it's really the substrate for network effects. Anyway, you can go into this through this repo. The features are explained. So what it means that we integrated basically the agent is going to be able to perform knowledge graph queries using the Sparkle query language, combine those results with other results from internal search done by Eliza, enhance those responses And then it's going to be able to create knowledge assets, basically memories. In this case, there's also providers inside of the plugin and so on. And if you want to follow along, you will need these as prerequisites, which are the same as for ElizaOS. Probably you can work with lower version of Node.js. I've been playing around and I found that 23.3 was recommended for Eliza, and that worked for me well. I tried some other versions. I don't remember exactly which ones didn't work, so that's why I looked it up, and then that made it work. And yeah, so basically, what can we start with? We can just go ahead and clone this repo. We just see where's my cursor window. Okay, I need a new one. Okay, so here's, I'm using cursor because it's great. And I'm just gonna go into, and we're just gonna create a new folder. Let's say we're gonna build an agent. I actually have a cool name for it because I made a Twitter account for it, and inspired by Marco, who had some similar idea. Let's call him Daniil Kek Gordon, or short for DKG. And so in that folder, I'm just going to put what I need. Okay, and then I'm going to start a new terminal window. Why doesn't it let me start a new terminal window? Let me start. No, it doesn't care. Okay. What am I doing wrong? Does anybody know what I'm doing wrong?
I'm not sure on cursor, but I guess you can like command and the tilde thing. It's the shortcut for creating a terminal. Or is it not letting you?
Doesn't care. Okay, we'll see. We'll see. Terminal. There it is. Okay. Maybe I just needed some rubbish in here. Okay, so terminal. I'm in this folder. What I want to go and do is I want to, not this, this. I want to clone this repo. So that's, if you want to do, if you're following and we've never done this, I'll try to do it a little bit slower. So basically you can copy the address from here or from here. And what you then want to go and do is you want to go git clone this. And then what happens is basically this tool called git, it's a great thing. It's going to copy everything from that repository. And now it's all here. So, folder showed up, Eliza graph. I have this bullshit thing. I'm just going to close it. And pretty much the code is there. So I'll just keep following along. So what it says here, let me just maybe do this so we can, literally what you have to do is just follow along. Now, first thing I'm going to make sure is I'm running the right version of Node.js. Come on, what's happening here? My mouse is going crazy. So proper version of Node.js. I have a tool called MVM, and this tool is the Node version manager. So basically it lets you install different versions of Node.js. I don't know why I have version 6. It's probably some problem. Anyway, I want to use this 23.3 because I know that one works well on my machine. So we just do this. And once you do that, you can just confirm that it's all good. So this, just put this up. NVM basically points with this little arrow telling you what is the active version. So version of Node.js that I'm currently using in this project is 23.3. PNPM I already have installed, Python 2.7 I also do, so, but it would take too much time to go through all of that. What I'm just going to do is I'm going to do this. I'm going to copy this PNPM install. I'm then going to go do this run, build. I'm not going to lint because it's just going to take time and nothing special is going to happen. But let's see if this works. Okay, log file is up to date. What did I do? No, I didn't go into the folder. Okay, so first you need to access the folder, cd, change directory. And then you do pnpm install. And then it complains. Why does it complain? Because I have this frozen log file flag that I need to use for this first time. You'll probably run into this as well. Once you do this, it shouldn't give you trouble, and you shouldn't really do npm install much, at least if you want to run this first thing. Okay, and now it takes a few moments to do this whole thing. What's happening right now? It's actually downloading all of the dependencies for the project, including, for example, as you can see here, plugin DKG. So, but also like a bunch of other things. On purpose, if you check out the repository code, actually, why don't I do it here? You will see that if you're familiar with Eliza, you have a bunch of folders here. We'll go through them. For example, the characters folder allows you to specify the character of your agent. There's a docs folder and so on. And then there's these packages under which there's, in the official Eliza monorepo, there's much more stuff. We've removed a bunch of them, not because we don't like them or anything, just because it was actually very tricky. For those of you who have tried Eliza, might have ran into such problems that because it's such a new framework and experimental and everybody's building in their own plugins, you can run into build issues depending on what machine you're using. Is it Linux or Mac or whatever? So for the time being, as we ran into some of those issues, we basically removed a lot of those plugins. So we left a few run. But basically what we're working on is seeing if they conflict with our code. I don't think so. I think it was the environment we had. But anyway, this is a thing that we're working on so we can push the plugin into the official Eliza repo, which would then allow you to also clone their official repo and just do it. But you necessarily don't need to, because this is a full implementation. So if you want to run an agent, you can just take this, clone what I just did, pnpm install, then you need to do pnpm build. And if that is successful, you're pretty much set to go. That's all the code installations you need. It's going to take maybe a couple of seconds, so let's give it some time. And meanwhile, while that is executing, we can just go ahead and check out one important thing here. So, yeah, see, it's building the plugin DKG. Okay, it's done. All right, that was pretty cool. Okay, so pretty much we got everything done. Like I said, you don't need to do this linting, but if you want to, you could. What that does is basically checks a bunch of code rules that you defined in terms of both code structure and all kinds of cool things. So if you're a developer, you probably appreciate linting quite a bit, but for the purposes of this tutorial, it's not really necessary. Okay, what do we do next? So we need to set up environment variables. What are environment variables? Well, they're usually in this file. It's called .env. The reason why it's dot in front of it is because normally these dot something files on Unix-based systems are hidden. So here's an example, and you want them to be hidden because this environment file basically contains a bunch of sensitive information. For example, OpenAI API key is something that we're going to be using for this example. So I will paste it here. Then we're going to be using also other things. Actually, in order not to show this key in the video, I'll copy my end file from another place. But what you would generally do is you would basically take this file, and you can either come here and rename it if you want, and just remove this example part, or you can do it like the old school way. So, and because I'm old, I'm going to do it the old school way, and you just move it, which is the way to remove it in Unix-based systems. And now you have .env. Okay, so this is the important part. If you don't configure this well, then it won't work, basically. That's it. So I'm just going to go and explain what kind of demo we're going to do today. So we're going to create a Twitter agent that uses DKG. Anytime you speak to it, you tweet at it, basically. It's going to take your tweet and create a memory out of it, which it does by default. Which code is responsible for that? Well, you saw it briefly here. So packages, plugin DKG, and then this plugin DKG, you can pretty much explore. We're going to look at it a little bit. We also have plugin Twitter. Where is it? Here it is. Web search. There's a bunch of plugins, so you can explore all of them. But for the DKG one, we're just going to take a quick look. And we're also going to very briefly introduce some concepts from Eliza framework. But this is not a video for that or to call for that. You can also do that. There's a bunch of really good videos. I think 4 videos created by the creator of ElizaOS framework, Shaw, who recorded everything, like, you know, 0 to hero, literally. If you haven't used Git, if you haven't used NPM or anything, you know, just take a beer or coffee or whatever and invest a couple of hours and you'll learn the whole thing. He did it really well. I really loved what he's. I saw some of what he's done and it looks really, really good. So what is the structure of these plugins in Eliza? Well, basically they have these 3 abstractions: actions, evaluators, providers. I believe there's 3. Maybe there's more. I'm not sure, to be honest. But basically the point is, and I'll try to explain very briefly, the action is what the agent can do. The provider is what the agent can sort of read. So this is your input. This is your, let's say, output. The agent does something. And then this evaluator is kind of a post-activity type of code that is going to evaluate what happened. For example, if the agent did a good job, or did it answer correctly, or something like that. I haven't made evaluators, to be honest, so I'm not the best person to ask just yet. Where I'm going to jump into that as well. And you can see, for example, here, what is the most interesting, I think, is these 2. So DKG insert, if you go in here and explore the code a bit, you'll see like how it works. And today we're actually going to use the Twitter client. So there's a bunch of stuff here, including the prompts. And there's also, oops, so I have a new mouse and I'm still like a noob with using it. And then there's this graph search, which on the other hand does queries on the DKG. So it's basically going to query using the Sparkle query language. There's some to-dos, by the way, if anybody wants to jump in, knock yourself out. That would be some great contributions. And anyway, it's not a lot of code, actually. It's also, when you look at it, it's actually executing the DKG, the query on the DKG. It knows how to prepare it, and then it uses that result in the agent brain, effectively. So I got somewhat sidetracked. So the end file is basically your configuration. You don't have to change any of the code. I just went in there to show a little bit how the plugin DKG looks like, but basically you don't need to touch it. If you want to run your agent, all you need to do is these 3 commands I did. So basically git pull, here it is, git clone, then you do npm install, then you do build, and pretty much after you set up this env file, you're ready. So what will we need? Well, we'll need this OpenAI API key. So you will need to insert your key here, and I don't know how to type, insert. All right, and then now there's all kinds of things here. I don't know exactly what all of it is, to be honest, but like, I mean, you can use the Grok API key. You can use all of this. You can use. So up to you to jump into it. There's some even default things. What we're going to use today is this. So, for example, for this Twitter agent, you're going to have to provide your Twitter username, your password, the email. Not sure how this works exactly. I'm not going to use it. But basically, I'm just going to provide these 3 to the agent. And I'm also going to copy that so it's not directly visible here. But ultimately, that's pretty much it. So that's the usual. That's like something you can see in generally other Eliza resources. What's not the same is this stuff we put at the end. So this is the DKG specific variables, and we probably should name them something more like this: DKG environment, DKG node. But that's a to-do, I guess, to note down. So it's easier to understand that this is relevant for the DKG. But for now, it works like this as well. So I'll just go one by one and explain what each of these are. But you also have, let me see if I can do ref. Yeah, okay, so this is better. You can also read these comments, which basically should explain it. And predefined, it comes connected to base testnet. You just picked it randomly. So one by one, there's 3 possible environments you can pick. You can run your agent on DKG mainnet, which is where you want to run it in production. This is the productive network, the most secure one, and the one with the biggest amount of knowledge, the biggest collective memory from an agent perspective. If you want to run it on the testnet, this is a network where you kind of play around and build, and it's essentially code-wise is the same as the DKG mainnet. It's just a test network, so it runs with test tokens, much less capacity, much less knowledge, and it's just kind of an environment to play around with. You can also run a development environment. That is, if you run the DKG network locally on your machine, which you can as well. You can find that in the official docs. Maybe I can just show you that here as well. So if you like, there's a bunch of ways to do that. So there's this is how to run the node on testnet, how to run a node on mainnet, and there's the dev environment, which I'm missing to find right now, which means I'm out of date with the docs. So, but it's in there somewhere. You know, Marco, maybe where?
What you're looking at? Oh yeah, you can type development setup and yeah.
Yeah, development environment setup. Here it is. Yeah. So basically, if you follow this one, this is in the SDK. You will see how to run. Basically, it's one shell script and a couple of things. But you can say, okay, I want to run 10 nodes, for example, or 5 nodes of the DKG, and your node will start up and look kind of like this. Though I'm showing you V6 docs, so I didn't manage to find the V8 ones, which is also something we should look into. But like I said, we're going to fix up the docs quite a bit. Anyway, coming back to the env. So what we're going to do today is testnet. We're going to try in the testnet. I suggest you try in the testnet because it's probably easier than setting up a local network. That's if you really want to go hardcore deep in working with the DKG and building something custom in there. But basically, we're going to use a testnet node, and this is a public testnet node, so anybody can use it. It comes also as part of these docs. So if you don't watch the video, just copy it from here. There's also a public mainnet node called Positron. So you can take this one. These are like gateway nodes. So what do these nodes do? They allow you to connect the agent to the DKG and publish and query knowledge using that node, kind of like RPC on the blockchain. The only kind of thing you don't get if you use such a node is you cannot create truly private knowledge assets, which is also a feature of DKG. You can create private knowledge, not just public, but that only you or who you allow can access. But obviously, if you're, I don't know, for example, if you're using my node and you create private knowledge assets, I'm going to be able to see them. So, like I said, you kind of cannot truly create private knowledge assets unless you really own your own node. But that is a more advanced feature, something for later. So for now, you can totally use these for mainnet and testnet. The default port is 8,900. Unless you run your own node and you want to change it, you can just leave that like it is. And then these two things are pretty much what is your agent's wallet. So the SDK or the agent needs public key and the private key to be provided here. And I just have some test, let me just grab it. I have some test public key and private key. So basically it should look like this. You copy your address and then, let me see. Yeah, by the way, maybe I can show you this. So basically in MetaMask, I created just like a demo account, and if you need a private key, you can go here, I think, account details, and then you can show private key. I need password. If I know the password, maybe I don't. Come on. Okay, I got it and I lost it. 1 second. Never disclose this key. I'm about to disclose the key. Anyway, this is a test. So this is the private key that corresponds to that. You can just copy it here to that public key and you paste it here. And maybe Marco, you can remind me, should I do 0x here or doesn't care? It shouldn't care, I think.
Yeah, it's fine. You can.
It's fine. Cool. Awesome. Here you would pick the blockchain that you want to use your agent to run on, basically. The DKG supports 3 blockchains. So NeuroWeb, Base, and Gnosis. And each of them has a name like this, which is basically part of the URL. So this is the blockchain name and blockchain ID, network ID. I don't know, Ethereum has network ID 1, Gnosis has 100, and NeuroWeb has 2043 and so on. So basically, if you want to do, I don't know, Gnosis testnet, you would copy this and you would just paste it here. But because I don't have tokens on this wallet on Gnosis, we're going to use this. So basically, this is the custom DKG, plugin DKG part. That's what you want to set up. And like I said, just go through these comments and they should take you where you want to be. Unless there's one thing that's missing here, which is you need some tokens on this account. So you need some track and you need some gas tokens. Now I pre-populated those, so I got some, but you should be able to get some in the faucet. And I know the last couple of days we had some trouble with the faucet, but we're working on it. Maybe did we fix it today, or is it still pending? Do you maybe know, Marco?
Sorry, can you repeat?
The faucet. Do you know if
Oh
we
yeah,
fixed it
actually
today, or?
it's fixed for all networks now. One thing that people should
Nice.
care about is like if you don't have Nura on a Nura web wallet, you first have to get Nura and then get Trace. So you cannot get Trace first because your wallet is then not activated, basically.
Yeah. So where you want to go is here, right? This faucet bot. And here, see what Marco did. You just tell it to fund you on a certain chain, and there's a bunch of commands, and you give it its address. So basically, you can do that on Discord, and this is the final step that you need to get ready. Once you have that, once you have the N and all of this stuff set up, but like I said, what I'm going to set up also somewhat hidden, so that we don't get this key leaked, is I'm going to set up this, and I'm going to set up the Twitter stuff. And so that's the only thing. So I'm going to just do that I'm going to return this thing back. I'm just going to copy in the right end file, which I should have on the other screen. Let me just see. Cursor. Okay, should be here, yeah. Okay, so 1 second. And by the way, if you guys have any questions, feel free to shoot them. Okay, I'm here, and where am I here? Okay. So I want to do this, and I want to do. Okay, so I copied the N file from the other folder, which should work. And basically, now I am one step away. All I need is to set up a character. So there's these character files here that you might have ran into when you were trying Eliza. So there's C3PO, there's whatever, Dobby, something, Tate, Trump. Basically, the point is that you can have some sort of control of the character. So let me just do this, and maybe we can quickly run through it. I don't want to go through it in very detailed way. I'm just going to copy one and sort of modify it slightly so that it runs. But basically here you would define the name for your agent. So you would define which clients it can use. The client is basically something you interact with the agent with. For example, we'll use Twitter. So for today, we'll do this. And actually, you know what? I'm just gonna let's not mess up Trump. Let's not play with the president. But yeah, here you have, for example, bio. You can give it, and these all end up in kind of a prompt that sort of governs how this agent acts. I don't know. Trump secured the southern border and did all the stuff. It's a cool, funny example. But basically, here you would give it bio with these sentences. You can give it the lore. You can give it some additional knowledge. This all comes built in with Eliza. Then you can go with message examples, things like that. So if you haven't done it before, basically you can just kind of figure it out through this file. I'm just going to copy this guy, C3PO, and just going to be, let's say I'm just going to copy like this and do a new file. And let's say, because this guy is, let's say DKG character JSON. I'm just going to paste it here. So I'm going to start from this. And what I do want to do is I want to do OpenAI because I'm using OpenAI. I want to do, I should pick a certain model. In this case, not this Allen medium, but this. I know this one works, so I don't pick it for some specific reason. The only thing I know it works and it works okay. So okay, what did we say? Let me okay, Gordon. I can give it a name. And like I said, I want to do Twitter as a client. So that's pretty much it. Now, of course, I can play around here. I can say, I don't know. By the way, this name, Daniel, also here. Humanoid robot with a knack for solving problems. Okay. Extremely knowledgeable, always eager, all this, all that. Maybe we can add something like based on the character Daniel from Asimov Foundation series. Nice. And strictly follows the 3 laws of robotics. And you can do whatever you want, basically. Just keep going and you can give messages, examples here. How do you want it to address you? But for this particular case, like, it's, I'm just going to say it like this. And what I'm going to try now, and by the way, so what I'm going to do is, like I said, I created a Twitter character. This should be its handle. Let me just go to X. And okay, I got a bunch of notifications. There it is. So this is a burner account. Oh, okay. Temporarily restricted. This can happen. So what happened to me is I started it, I tested it with an agent locally, and then I think Twitter found it to be some weird activity because it had 6 posts. So I think I need to figure out, let me just see, maybe I got an email.
You could also try running it like sometimes it works and sometimes it doesn't when your account is restricted. And also you have the tweets from before I saw. So even if it doesn't work, we can show it.
Yeah, I also have it. Here it is. Your account has been locked. Okay, so what I need to do is verify my email address. Okay, let's just. So if this happens to you, just log into the account. They will ask you to send an email, and they'll send you a number. And okay, so this guy. He's actually I tested it just before, so we don't run into some stupid issues. Let's see if now it works here. Okay, awesome. So yeah, let's just run it. And the way to run it is basically it's very simple. You do PM start, and then you do characters, I think. And then we have to do characters / DKG character JSON. Let's see if I typed that correctly. And now you kind of want to follow what's going on here in this terminal log. So actually, what I'm just gonna run through it a little bit. So see, there's a bunch of stuff. We don't want to dive too deep, but it's basically going to give you in blue. There's going to give you a bunch of these information. At some point, it's going to give messages that it successfully started the agent runtime with the right name. So that means I got the file right. And then at some point, it should tell you that it loaded the DKG plugin. So I'm just going to look for it. Okay, I don't know what this is, but we got some users and somewhere here, maybe even at the end. I'll just see. Okay, so somewhere before, even created me as a user. I'm not sure what this is. This is Discord, right? Did we connect it to Discord, perhaps? You know, Marco?
I think those are like mock users.
Mock users. Okay, yeah.
And your one is from the history, I guess, from Twitter.
Yeah, so I found it, but I don't see where it initialized the DKG plugin. Should show me that.
Yeah, to be honest, I don't remember if it sets it up after you tweet or immediately.
Could be. could be. Anyway, I mean, it did because I see the queries, but I just wanted to find the message, because when you find a message, you kind of can immediately see, okay, things have started well. But I also see the things have started because I see this knowledge graph query, and I don't expect it to run without the DKG plugin. So what actually happened here is it already is creating some memory, because as you can see here in the logs, it had tweeted. So what we kind of basically want to do now is I want to tweet at it. So let me just post and be like, okay, for example, do you know of any other laws robotics than the 3 Asimov laws, for example? And if I ask it something like that, I'm gonna just my cursor window. Did I just move it? Yeah, here it is. So now basically the engine is running, and it's running on my machine. So the difference between, let's say, you launching an agent to run continuously and doing development is that, like right now I'm doing this on my machine. I'm editing all this code, and pretty much what you should do, how you want to deploy this, is you push it to a server, like ideally Linux-based server. We tried, by the way, Ubuntu 20.04 didn't work for us. Some issue with the libraries not compiling or building, I don't remember exactly, but 24.04 did. So if you want to deploy Ubuntu 24.04, for sure it works, and we should put that in the docs, by the way, too. What's going on right now? So the agent, you can see some of these messages, like it saw some tweet and it's skipping it because it already responded to it, and it checked Twitter. And there's some configuration, I think, in the app file of how often it checks. I didn't set that up, to be honest, but there's like, Twitter poll interval. It's 100 every 2 minutes, basically. By default, it checks Twitter. And I think somebody picked that in a clever way, because if you do that more often, let's say every second, you're going to get in bigger trouble than I did at the beginning. Twitter is going to block you pretty much, I think. Not entirely sure, but there it is. Tweet sent 3 minutes ago. But basically what I sent it a message because I was testing it an hour ago. And I can show you that while we wait. So I asked it about the 3 laws of robotics, and it answered to me what are the 3 laws of robotics, and also created a new memory. And this new memory I can explore on the DKG testnet, which basically is the memory, the knowledge graph of my tweet. So you can see the tweet here. Hey there, what are the 3 laws of robotics? And to create this knowledge graph, it actually analyzed this sentence to understand what's the point? What are the entities in this? What's the meaning of this? So it actually realized that it's an inquiry about the 3 laws of robotics. Who was it? It was this guy, Brana Rakic, and his Twitter handle, and the time. Okay, the timestamp for sure is not correct. We need to check what's up with this timestamp. But ultimately, it picks out all of these relevant entities. So the people involved, or the agents involved, the concepts, 3 laws of robotics, the keywords, robotics. Maybe I can zoom this out. All these things it kind of picks out by default. And what I want to show you is how you can improve this. So you can make this graph richer, and the richer the graph, the more context the LLM has when it reads it and so forth. But ultimately, I just want to see it actually run one time. So, okay, this looks good, actually, even though it looks weird. This is a log of something we expect. So we can inspect it a little bit more. Now, what happened here? Some errors, but these are actually not errors in the sense of that this should worry you, because it didn't find an action for something they call continue. It's an ELIZA thing, which basically means, don't do anything continue. And because it thought it should do continue and didn't find some specific action, it sort of screams at you that it has an error. But actually, when you look at the log here, so we were somewhere here just a few moments ago, it actually caught my tweet. And it responded to me. You can see the response here also, and we'll just check it in Twitter in a moment. And then after the response, you can see what happened is it actually created a knowledge asset on the DKG. I know that because of this asset created log and publishing message to DKG. This can last, depending on the blockchain, somewhere in between 10 to 30 seconds, whatever, because it does a transaction on chain. And then after this transaction, it broadcasts this knowledge to the rest of the DKG nodes through that node that you set up initially in the app file. We can work on this for sure, but this is basically the serialized graph. And it has a bunch of information in here. And so essentially, this is what the normal log at this point looks like. We're probably going to make them better. If you have any ideas that you can improve them, please do. Just feel free to contribute, and we'll come to that in a second. But before that, I just want to come here and see. So yeah, I see a bunch of notifications, so it should have responded to me. I don't want to open this because they're going to disappear and then I'm going to miss something. But yeah, see here, 4 minutes ago, I posted and then it reminded and responded that actually there's a fourth law, or what they called, sorry, this is, I'm missing one response. So this is Twitter not showing it well. I saw that it actually responded with a zeroth law, which is something that Isaac Asimov introduced after he actually did quite a lot of butchering of the three laws, because all of his robotics books are actually about sort of circumventing these laws and how robots or agents can misunderstand them, because there's edge cases that are very weird and interesting once you start getting into it. So he actually introduced the zeroth law, which is, so the first law is that the robot cannot hurt a human being. The second is that it has to obey human beings unless that conflicts with the first law. And the third one is that it has to preserve its own existence unless that conflicts with the first two laws. And then he introduced the zeroth law, which is that the robots have to protect humanity as a whole, which, and in these edge cases, he found basically a case where this wasn't correct and this wasn't like true. So it's really cool. Anyways, basically all of you can now just go and tweet to this guy. Like, so if you want, he's running from my machine. You can try it out. I can post it here. Where's the chat? Okay, I'm still a big noob in this one. So where do I click? Okay. Where's the chat?
I'll do it, no worries.
Okay. Yeah, boomer here, but I managed to find it. Here you go, guys. And yeah, this is kind of one-on-one. This is how you can start it. Now, what you can do with it, what's some extra stuff that you can play around with, which we're, by the way, somewhat out of time, so I'm going to speed it up a little bit. But basically, what you can do is you can take the plugin itself, or you can just take the rest of the code. Like you can, for example, this is the code for the agent. And there's a bunch of stuff in here that you can look into. I don't really have the time to explain much about the inner workings of ElizaOS, but like I said, there are some really great videos. And you can change its behavior quite a lot. You can, for example, add other clients and things like that, but you can also pretty much do whatever you want. But if you want to really go knowledge graph way, really dive deeper there, basically, two ways you can do it. Either write some custom code for your agent, or you can actually contribute to the plugin DKG, which would be great, because if you're building something a little bit more general, then others could benefit from it, and then you could also pull in some cool features, of which we can suggest a few. And but anyways, like I said, for example, if you want to change the way memories are stored, and this is just a basic predefined way of creating memories that comes with the plugin, which is obviously needed because the plugin is a more general thing. Like you can, for example, change it here. So you can take this DKG insert and you can actually find the prompt. And we can do a lot just with modifying this prompt. So let me just do wrap again so it's easier. So here, there's this is the prompt, which basically tells you, tells the agent or the LLM how to create a query. And I'm not going to read through it, but basically you can just go to the repo and see it. It tells it all kinds of instructions, how to store certain elements and so forth. And basically what we're using here is something called an ontology. And I think the prompt changed from last time I saw it. Okay, here it is. So one instruction says to ensure that all fields align with the schema.org ontology. Okay, what is an ontology? Let's go there. An ontology is basically the codified knowledge domain in a way. Schema.org is a famous one that has been agreed upon by major browsers. So you can see Google, Microsoft, Yahoo, Yandex, they all use it. And why they use it is in order to basically have a shared way of indexing websites. So, for example, if you want to improve SEO of your website, you want to add schema.org annotations to your website, and Google should reward you. Like nobody knows exactly how their algorithms work because they're proprietary and Web 2 and centralized, but it's believed that the more context Google has and better it can understand, the better it will run. The better it will sort of rank your website. So you can explore these called schemas. For example, I don't know, you can go and see what a person looks like. And a person is basically a type of an entity, or in the world of OriginTrail, of a knowledge asset. And a person has all these potential properties. It can have an address, it can be an alumni of something, it has an email, family name, whatever. And so this is pretty much your, let's say, equivalent of object-oriented programming object, the way you model it and the types that you define. This is like a global type that these browsers have, these browser companies have started, but a lot of others are using. And basically the LLMs should know of these major types. They actually know quite well. Now, do they hallucinate? Perhaps. And there's ways to basically make them more precise in generating this. You can also generate, for example, since we're working with Twitter, we could sort of adopt a sort of rigid static structure that we expect the LLM to populate, or not even the LLM, we can just like extract the tweet and the poster and the timestamp and whatnot. So these things, so you don't have to use an LLM, but like what's very useful here is that all of these things are they're like juicy for the LLM, because as you can see, for example, I don't know, here, let's say if this person is a performer in some event, this is also a type. So this connection already is relevant for something which is a knowledge asset of type event. And then this type event has its own audience, and like this video call or actor or director or whatever. So basically these guys have kind of modeled the domain. They modeled what's possible, what kind of things exist. And actually all of these inherit each other. For example, the event and the person, they are a subtype or subtype really of something called thing. This is a very abstract type, which is, anything that exists. And it can have an image, an identifier, whatever, and it can be same as something else. And, so this is just super simple intro. There's other ontologies. For example, gene ontology is one for obviously genetics, and here it says, Ontology is knowledge base is the world's largest source of information on the functions of genes. And basically, we can search, for example, what could we search? Like, I don't know, protein folding, for example. I think that should show up. And what we just found here is that, okay, it ran a search. Okay, in the ontology, let's see what this gives us. Okay, protein folding is a term in the ontology. Now I'm just going to open it. This is a website, by the way, that explores the graph. Ontologies are also stored as triples, as graphs, which is amazing because in the same graph, you can have the data and you can have the actual knowledge that explains the data, or extremely rich metadata. It's something you cannot do with any other data structure, and in such a way that you can with knowledge graphs. So here you can see, for example, that this protein folding is a biological process. It has certain synonyms, which I'm not even going to try to pronounce. It has certain IDs, and this is actually its ID. You can see it by the URL. This is the Web 2 UAL. And the difference between this and what DKG URLs are is that this thing, just anybody can create, so there's this, but like these, you don't actually know when somebody modifies what's behind that ID because there's no data provenance built in. You don't know who's the owner because you kind of assume it's whatever, this organization, and you cannot transfer ownership. You cannot, there's a lot of things you cannot do. So the DKG introduces really a huge innovation with knowledge assets or memories for agents by introducing the URLs. Very exciting thing. Plus, the URL is globally unique. Somebody can create this ID or this whole ID also somewhere else. And it's none of these are, it's hard to make them globally unique. That's why they actually use URLs as much as possible. But if you want to not use a URL, it's hard to enforce some uniqueness. While blockchains, we can do that because just as we can prevent double spend, we can also prevent duplicate IDs. Anyways, there's a shit ton of useful knowledge just within an ontology. And you can even see, for example, we can go, we can explore this graph views, for example. And for this particular term, protein folding, you can even see an ancestor chart. So it's kind of a sub-process of protein maturation, which then has these things, and then it's also cellular process. And this is also a graph, right? And even this graph has certain different types of connections that you can look into. And we can probably also explore, I don't know, metabolic process. It has a different ID. So long story short, some great minds and extremely knowledgeable people built out this gene ontology, and it makes sense to use it. You can also see the JSON file of it, which is quite huge. But basically, point here being is that if you can, you should reuse ontologies. So you shouldn't make your own. But if it doesn't exist, it's not a bad thing to create your own either. It's not like blasphemy or anything. So for example, if you're running an NFT project or something, you can create your own ontology, pretty much describe it in graph terms, and then you can go and have your agent use that. You give it examples, and then with those examples, it can build that. What's amazing with reusing ontologies, though, if there's multiple agents, if there's a swarm, and then they all know how this ontology works, including people, then you can basically expect them to be able to understand other agent memories. Okay, I have about 5 more minutes, so I'm going to just quickly run through this. If you want to if you want to create an agent, if you want to change how how memories are created, you want to jump into this DKG insert file in the plugin DKG source, and you want to modify this prompt. This prompt also contains this DKG memory template. If you go there, you're going to see some template which we created just as kind of a general template based on the schema.org ontology. And because this is initially set up on Twitter, we use the social media posting type, which you can also explore in the schema.org. And then it has these fields. But you can totally go ahead and, for example, let's do that. Let's just go to schema.org, and I'm just going to search social media posting, and it's going to give me that type. I don't know. Let's pick something, something random. For example, sponsor, for example. Or I don't know, if we want to talk about this person who is sending the message, we might want to take something. Oh, by the way, yeah, you see this, these are all properties of this particular type, so social media posting, but then at some point when you scroll, you're going to run into what it inherits from others. Here it says properties of thing. So for example, image, you can add an image. You can also add other things. You don't have to strictly stick to these, but if you do, that's good. That helps the LLM and that all of the graph tools you might want to use. I don't know, for example, we can add publisher, which is a person. So for example, I could go here in this prompt and I could, in the template, maybe we already have publisher, I'm not sure. We don't. Okay, so we could, for example, I don't know, just do here. So I could say publisher, and then I could have let's say, add the name of the person or entity publishing the memory. For example, this is what it was okay suggested by Cursor. And now this is going to be part of the prompt as well, because this was the template. So back to where I called the template, which is here. As you can see, part of this prompt is that this template is included here. So you can just change this template in the constants file, and immediately it's going to have another field. So it makes a richer graph, a richer memory. Now you want to test it, see if this works. Maybe this is not the right way to do it. You can also do something that's not an LLM related thing. Like you can, for example, populate this with just classic JavaScript. Also, there's you can also play around with this, like what was the user query, or really this tweet that was coming here, or additional context, which you can also explore what it exactly is. But ultimately, at some point, you reach this function that constructs, basically this function constructs the knowledge asset that you send it these things in, but basically you can just edit this function. And there's a to-do here that we added that also somebody can jump in, that this is not just based on one query, but a whole conversation, because actually it runs a query, and like I said, it uses this user query. And after that, basically it performs this DKG action, which, and I'm just going to quickly run through it. There's a bunch of things here that that are kind of just intro to the whole thing, but this construct knowledge asset is the main function. So you might want to explore that. And if you go inside, like I said, you can change all these parameters. Once you construct the knowledge asset, you come to the main thing, which is the creation of the knowledge asset. So the DKG client is embedded into the SDK of the DKG. In this case, DKG.js is basically exposing all of its methods so you can use them. And in this case, we'll create this public memory, and we give it 12 epochs, which is 12 months on V8, but you can also change that. So this is just the default one, and it's going to log whatever happens, or if it doesn't work, it's going to log an error. This is where it posts a tweet. You can also post a different type of tweet. So here it says it created a new memory, whatever. You can change the text. You can play around. You can change the examples. You can do all kinds of things. And similarly, on the provider side, the graph search does a similar thing. It just doesn't create. It does, let's say, DKG client. Let me see where it is. Oh, pardon me. Friend is calling me because I'm about to meet him in 5 minutes. So let me just see DKG client dot query. Oh, what did I do? DKG dot query. Let's see. So this is where it constructs the Spartan query, but where does it call it? Here it is. This client graph query. Yeah, we changed this with V8, so I totally forgot. So basically, this is where the query is executed, and you can see that this is the search function. You can sort of dive deeper into it. All right, Marco, you've been following along. Did I miss something important outside of in the code walkthrough? I have a couple of other things for CTAs, but do you see something important?
Yeah, regarding the code, no. I wanted to say about the CTAs, but if you got it, you got it.
Awesome. You want to take over the CTAs on GitHub?
Yeah, I mean, sure, quickly. So, yeah, we have this plugin live on the OriginTrail GitHub. It's pinned in the agents channel. And yeah, we have some ideas on how to improve it. And for sure, we'll be, let's say, taking action on some of them. But we invite any of you, while you're trying it out, while you're playing with it, take a look at those issues. I think most of them are like decent first time, code contributor issues. So yeah, it would be great if you take a look and perhaps develop what we wrote there. Yeah, I described all of those issues like shortly, I guess, but feel free to tag me in the Discord if you want more like explanations and stuff.
There is a question. Using LangChain LangGraph framework with DKG should work as well, right? Have you tried it? Yeah, it's possible, absolutely. Marco, you had some more experience with it than me, so maybe you can pitch in.
Yeah, I mean, it's possible for sure. I haven't used it in a while, But yeah, if you want to try it and you have some issues, yeah, let us know. Also, there's a plugin for Eliza, I think, with LangChain. So that's also possible.
And feel free to, if you find a bug or something, post an issue here, guys, or like an idea. Like these are just some initial ideas for both features and some small to-dos that can sort of get you going easily. But yeah, anything you might have as an idea, just like pop here, new issue, and go and create one of these. So that would be really awesome. Okay, it's been an hour and a half almost. One final CTA is we're organizing a hackathon, to which, by the way, we could consider an intro. In Belgrade, Serbia, it's an in-person hackathon, so it's not online this time, but we'll probably do that also at some point in the future. Basically, we're building AI agents at the hackathon. We will post the details of the challenge in the coming days. It will also be streamed online. So we're going to have the hackathon last for a couple of days before the actual event. And on the event, on Monday 27th, we're going to have folks present what they built. We'll also have a couple of partners joining in and having some very short talks on agents and what's the latest in the world of DQG and agents at the intersection. So do come to this page. I'll post a link. Register if you want to join in online. It will be possible to watch. The whole team pretty much will be there. The people on this image. This is taken at DQGCon in Amsterdam. Team and community. I see Amos, who's on the call. I think I see Amir. Hey guys, welcome and thanks for being here. And yeah, just if you're in Serbia or around Serbia, we invite you to come over. There'll also be some beers and all kinds of cool stuff. You'll be able to meet a team and just build out something exciting and potentially win some cool prizes. Again, we will share those in a bit and watch for this page and for the official announcements. I hope this was interesting. This is the first time we do something like this. We wanted to do it a bit more spontaneous and with a little bit less prep than it kind of sometimes you have to do for a conference and slides and all these things. So let me know or let us know. So anywhere, in the Discord or in wherever, Telegram, how you found it. We'd love to hear feedback if we can improve somehow. Should we make it shorter? Should we make it longer? Should we dive deeper into topics or less deep? I don't know. Maybe I bored you to death with some of these things, or maybe it was actually exciting. To me, it's always exciting, so I go there. But if I can totally understand if it's not exciting for everybody. And yeah, I guess that's it. I kind of need to close here because I need to run. But again, thanks everybody for coming. I hope it was good, and we'll do these more often.